All right, awesome. So a couple other things we want to keep in mind here, though, is when we're picking the winner, when we're waiting for that random number to come back, we probably don't want anybody else to enter the raffle. So what we can do then, we can add a new type to check the state of the raffle and see if it's open or not. If we're in the middle of picking a winner, we can say, hey, we're in the middle of calculating the winner. You're not allowed to enter the raffle. So we can create a new type using something called an enum. So to keep track of the state of the blockchain, we could scroll up to the top. We could say, okay, we create some state variable like a U256 calculating winner, or better yet, bool calculating winner equals false, and then just update this. But oftentimes you're going to have a lot of different types of states rather than a binary calculating winner, right? Maybe instead we have a lottery state where it could be like open, close, calculating, etc. We don't want to have a different variable for all these different things. So what we can do is we can create a single variable of a new type that we create called an enum. And this is going to be a type declaration. So this is going to go above all of our state variables, but below our errors. So right here, I'm going to make a new section called type declarations like this. And we're going to create this new thing called an enum. And in the Solidity docs, we have this section called enum types. Enums can be used to create custom types with a finite set of constant values. They are explicitly convertible to and from all integer types, but implicit conversion is not allowed. So we can see here's an example contract, and there's this enum action choices: go left, go right, go straight, sit still. And so once we create this enum, they get this new action choices typing that they can use throughout their contract. For us, we're going to make an enum called raffle state. And this is just going to be open or closed, or excuse me, open or calculating. So either the raffle is open or it's calculating, and you should not be allowed to enter the raffle. In Solidity, these can be converted to integers. So open would be 0 and calculating would be 1. And if we added more, they would be like 2, 3. Like if we added more states like close, some other state, right? We could add more like that. But now we have this raffle state variable. What we can do is we can create a new storage variable. So we'll do raffle state private s underscore raffle state. And what we can do is we can default this to being open. So in our constructor, we can say s raffle state equals raffle state dot open. And what we could do is in our enter raffle, we could make sure that the raffle is currently not calculating a winner, right? So we could say if s underscore raffle state does not equal raffle state dot open, then we're going to go ahead and revert with a new error, raffle underscore underscore raffle not open, like this. And we're going to create a new error up here. Say error, paste that in, raffle not open. So you can only enter the raffle if the raffle is currently open. Now, down in pick winner, what we're going to do is before we send this request, we're going to set the state of the raffle to calculating. So s underscore raffle state equals raffle state dot calculating. And now, while we're waiting for the random number, since it's calculating, people won't be able to enter the raffle, which is good. That's what we want. And then, of course, once we get the random winner back, we're going to want to flip it back to actually being open. So once we get our winner, we're going to say raffle state equals raffle state.open. Awesome.